the big thing that we have accomplished is this board, this charge controlling board. Lithium iron phosphate batteries takes a certain algorithm to charge. When I started this, I tried to find something off the shelf, it just didn't exist. One of the things I wanted to make sure we had was what they call MPPT, which is maximum power point tracking. And what that does, this communicates with the solar panel to make sure we get the optimum out of that solar panel. The other benefits that we have, one is wireless, which we're the only one for lithium iron phosphate that has a wireless system. The other is a buck boost chip. What that does on a day like this, it's very cloudy, we can produce energy where most of them can. This is a 25.6 volt system. If this drops below 25.6 volts, it puts nothing in the battery. But with our buck boost chip, we can be down to 17 volts and it still puts it in there. The other thing that we're able to do, a normal charge controller can only push this to about 26.5 volts, the batteries. But with the buck boost chip, we're able to push it up to 30.2. The maximum these batteries can hold is 30.4. We wanted to go just a little under that threshold. So we're able to push it a lot more on the top end, and we're also able to extract a lot more on the bottom. So that late in the evenings, you can put something into the battery. Cloudy days, snow days, it gives you a lot more area that you're actually putting into the battery.
How does the boost come?
It's in this board that we invented.
Okay.
And this is our wireless communication board here that's communicating with that. Over 10 years ago, when I started researching the batteries and everything came back to the lithium iron phosphate battery, the problem was this one cell was around 80 bucks a piece. So back then it was not viable. But now you can buy this same cell for about 15 bucks. So it's
all three of them, or
no, each cell.
$45 per stack.
Right. So it is at a point now that it is viable. Instead of 50 cents to $1 for installation, we're at about 2 cents. There's a huge savings, and the same guy that hooked the solar panel up can hook this up. Everything, all this is done in the factory, so when it comes, it's already been pre-tested. The FCC approved communication system we use will automatically come online when it's in the area, and every time you put another one in, it just automatically comes up and has its own identification and allows you to be able to access it. Rayon's son, Daniel helped us hook everything up. One of the things that we wanted to accomplish was that basically a 10-year-old could hook our battery system up. Very important when it comes to third world countries. In America, we have the technology or the technicians to be able to hook it up. But when you get to those areas, it's a problem. And some areas they won't even go. You go to Africa and some of those areas, you can't even get a technician there. This, when it comes sealed with tamper-resistant seals. This is a fireproof box it comes in. The ideal is when you get it, this hooks onto the racking system. The other thing we have accomplished is this board. This is the meat of the whole thing. This charge controller is specific to lithium iron phosphate batteries. These are some of the hardiest batteries in the world. I've been testing them for over 10 years. This has over a 10-year track record. It's hardy enough you could take a nail and drive through it as it's being charged. The other benefit is it can be ground up and put in a landfill. There's no thermal runaway, no memory. This has a 2000 cycle battery. So this is the battery of choice. Heat-wise, it is the most hardy battery for heat on the market. Very important when you go to some of the desert areas.
How much does that solar panel cost?
That one is about $250. But one of the nice things is we're not connected to any solar company. When you leave here, our line's here, it doesn't matter, as long as it can withstand the voltage and ampage, doesn't matter what it is. Same thing on the other end with the inverter. This is a micro grid tie inverter. Our system, it doesn't really matter whether it's a off-grid inverter or a grid tie inverter. It just puts out the same voltage, whatever. It doesn't really matter. So you could use any micro inverter, or if you're doing like this is a 300 watt off-grid inverter that we're using, and basically it's going to be powering these lights. And what that means that you can hook these up to 1,000 panels, and when the grid needs it, it's on demand. This is 5 hours of storage at a 300 watt panel.
What's the total generation? How much electricity does it generate?
Well, it's generating roughly 300 watts, 300 watt panel. So this is basically 1,500 watt hours. So this would run this for roughly, theoretically 5 hours, but you're not going to get 100% out of it.
Yeah.
But every time there's another board that comes in the system, it'll come up automatically on this screen. There's no hooking up. So if there was 10 there, there'd be 10 of these little icons. This one is actually reading the temperature every 30 seconds, this little icon here. This one is actually just turns it on, and you'll watch over there. So what that allows you to do is be able to access this power
On demand.
on demand. So what that does, that now makes solar viable. It makes it on demand, and it actually makes it the fastest power available. So within 2 seconds you can access it. If you wanted to access one panel or 100, whatever you need, and then you design the software necessary to meet your needs. You need to fill every time you have a lull, it just automatically comes on.
So each unit is controlled independent of
Right.
other.
The software that you have designed through the company that we're dealing with, it allows you to access it, and it's just that simple.